is Minh. I'm in group 7 and we have 5 members. It's Hữu Nhân, Đức Nhân, Hồng Ngọc, Quỳnh Trân and me. Today we will talk about the sickle cell anemia. In my part I will introduce about the pathophysiology. As you can see, this is the normal cell and the sickle cell. Sickle cell disease is an abnormal recessive genetic disorder affecting about 100,000 individuals in the United States and millions globally. The term SCD includes a mutation of the beta globin gene that produces a similar clinical phenotype. Sickle cell anemia, the measure of SCD results from the hemoglobin for the beta adhere on chromosome 11p 15.5. This mutation differs from the normal beta globin achieved by a single nucleotide substitution, leading to the production of hemoglobin S.
Hello, my name is John. Today I talk about the etiology of sickle cell disease. People with sickle cell disease introduce two hemoglobin genes variants from each parent. These genes make a hemoglobin protein. We call this hemoglobin S. Sickle cell disease can also occur when a child introduces genes for hemoglobin S. Sickle cell genes from one each parent and genes from different types of faulty hemoglobin. Such as beta thalassemia or hemoglobin C from the other parent.
So my name is Hữu Nhân and I will talk about the epidemiology. The epidemiology data on SCD is scarce. It is well known as SCD and hemoglobin AS are more prevalent in sub-Saharan Africa, where is the carrier of hemoglobin AS is afforded natural protection against severe Plasmodium falciparum malaria. It's estimated that about 203,000 children were born with SCA and more than 3.5 million neonates were born with hemoglobin AS in sub-Saharan Africa in 2010, and estimated about 75% of SCD related births are take place in sub-Saharan Africa. West Africa is the home of the largest population of individuals with hemoglobin SC disease.
Hello, my name is Ngọc. Today I will talk about presentation, history, and clinical examination. Sickle cell disease is an inherited disease which many people are born with it. However, most babies not have problems from the disease before they are about 5 or 6 months old. People who inherit only one copy sickle cells and have sickle cell trait, they usually don't have symptoms of sickle cell disease as carriers. They can bear the faulty and unnatural early symptoms. You can see rewound infection, extreme mortality or fusion from anemia, painful swelling of the hand and feet, anemia, delayed growth and delayed puberty, yellow color of the skin, truly or white of the eye, interest.
My name is Young. I will talk about the workup diagnosis. If an individual sickle cell carrier status or disease take now, laboratory evaluation is indicated. Hematologic testing shows that hemoglobin analysts can identify the deficiency of the hemoglobin S and modify its proportion molecular genetics. Testing can determine whether the patient carries on heterozygous or two homozygous pathogenic variants of the beta globin genes. Additional assays may detect other structural hemoglobin variants In cases where hemoglobin study yield inclusive results, molecular analysis can provide definitive confirmation of sickle cell disease. Certain individuals with SCD are compound heterozygote and inheriting one HBS allele and abnormal beta globin alleles, such as those associated with thalassemia syndromes, poor hemoglobin electrophoresis, and genetic testing are useful for identifying their variant, tentative, and related hemoglobin neuropathies. Moreover, people can also do prenatal and newborn screening.
To the last part of our presentation is treatment, and I will talk about this. I'm Mai Hữu Nhân. Sickle cell disease can be managed through two primary procedures, which is regular blood transfusion or bone marrow transplant. About the regular blood transfusion, which is doctors will deliver the healthy donor cells into patients' veins to increase their healthy cell counts and lower the risk of complications like strokes. But however, frequent transfusion can lead into iron overload, and which is maybe damage their organs. Otherwise, they will up, and others they will have infection or immune system reaction that makes finding future donor difficult. About a bone marrow transplant, this will involve swapping out the patient's deceased bone marrow with healthy marrow from the donor, typically a sibling who is close genetic match. And thank you for listening to our part. This is the end of our presentation.